Hey guys, it is Campbell here. Today we're going to be continuing our series solving all of the FRQ questions from the 2024 AP Calculus exam. Today's question 5. So question 5 reads, the function f is twice differentiable for all x with f of 0 equals 0. The values of f prime, the derivative of f, are given in the table for selected values of x. And as you can see, they give us a table up there. So part A says for x greater than or equal to 0, the function h is defined by h of x equals the integral from 0 to x of the square root of 1 plus f prime of t squared dt. Find the value of h prime of pi. Show the work that leads to your answer. So let's go ahead and start. We are told that h of x equals the integral from 0 to x of the square root of 1 plus f prime of t squared dt. Now you may remember this from yesterday's question, question number 4. When we take the derivative h prime of x, we are just going to get the square root of 1 plus f prime of x squared. So h prime of pi is going to give us the square root of 1 plus, we are just going to plug in f prime of pi, which is going to give us 6. 1 plus 6 squared, which is going to be 36, plus 1 is 37. So h prime of pi is simply going to be root 37. And that is all for part A. Now, part B reads, what information does the integral from 0 to pi of the square root of 1 plus f prime of x squared provide about the graph of f? This one is a little bit more tricky, but if you've been studying up, then you should know the answer. Or at least you should know how to be able to figure out the answer, if that makes sense. So this one is going to require knowledge of all of our formulas. So let's go ahead and recall our arc length formula. Remember that arc length, or S, is the integral from a to b of the square root of, in this case, it's going to be 1 when you're not working with polar or vector, right? Plus, f prime squared dx. So this expression it gives us, this integral expression, is an arc length formula. So we can say that, we'll just go ahead and rewrite the integral. We can say that the integral from 0 to pi of the square root of 1 plus f prime of x squared dx tells us the arc length of the graph of x, or f, excuse me, from 0 to pi. And that's all that we need for part B. Obviously not a terribly difficult question, but if you don't know your formulas for arc length, then obviously it's going to be a bit more difficult. Part C says use Euler's method starting at x equals 0 with 2 steps of equal size to approximate f of 2 pi. Show the computations that lead to your answer. Now with Euler's method, we always want to start with, I like to use a table, so we start with our x value, and then our slope, and our next value. Starting at x equals 0, right? So our slope at x equals 0 is just going to be 5, as it tells us in the table. So f of pi, which is going to be our next value, Remember, since we are using Euler's method, it is going to be an approximation, so its f of pi is approximately equal to our slope, which is going to be 5, times pi minus 0, plus, and it tells us that f of 0 equals 0, so it is just going to be 0. And this is going to be, of course, equal to 5 pi. So our next x value is going to be pi, because it wants us to find 2 pi using 2 steps of equal size. Our slope at pi is, of course, 6, so f of 2 pi is going to be, once again, approximately equal to 6 times 2 pi, pi, plus 5 pi. And this is going to give us 6 pi plus 5 pi, which is 11 pi, which is, of course, going to be approximately equal to f of 2 pi. And there is our answer for part C. Now up next we've got part D. Find the integral of t plus 5 times the cosine of t over 4 dt. Show the work that leads to your answer. So the integral of t plus 5 times the cosine of t over 4 dt. Now we recognize, hopefully, that this is a product of functions, so we're going to have to use integration by parts. I like to use this handy acronym for integration by parts. It tells us what, going forward, what u should be, and going backwards, what dv should be. And this is, of course, natural logarithm, inverse trig, algebraic, trigonometric, and exponential. So algebraic comes before trigonometric, so u is going to be equal to t plus 5, and dv is going to be cosine of t over 4 dt. du is just going to be dt. Oops. Let's make sure that they are able to be differentiated. This is du, this is dv. So v is going to be 4 sine t over 4. Remember, our formula is u times v minus the integral of v times du. So we've got t plus 5 times 4 sine of t over 4 minus the integral of 4 sine t over 4 dt, since our du is just dt. And this is, of course, going to give us t plus 5 times 4 sine of t over 4 plus, because the integral of sine is going to be negative, the negative and the negative cancel out, 16 cosine of t over 4 plus c. This is, of course, going to be our final answer. And that is going to be all for question number, what are we on now, 5? Should be question 5, yeah. I hope that you guys found this video useful. If you did, please consider leaving a like. I would greatly appreciate it. I will be doing the final BC question next time, and then we're going to be doing all of the AB questions. Yeah, so thank you guys. Again, please consider subscribing if you enjoy this content. If you want to see more, leave a comment telling me what kind of content you want to see, or what topics you want me to cover. And yeah, Thank you for watching this video, and I will see you guys next time. Bye.